everyone, welcome back to my channel. I'm going to teach you now how to solve some of the problems in this mock paper for HKIMO 2018 secondary 1 level. This is a 120 minutes test with 30 questions. I'm going to do now the first page of this test. First page has the logical thinking section with 6 problems. So we're going to answer all these 6 problems now. Okay, let's read the first problem. Given A and B are 2 non-zero digits and the 2-digit numbers formed by these 2 digits have the following properties. First, AB is divisible by 8. Second, BA is a prime number and is less than 50. Find the 2-digit number AB. Okay, so by looking at this problem, it looks like it's easier to solve this if we consider first the second property, which is BA is a prime number and is less than 50. Because we have in mind that that number is a 2-digit number and it's a prime number that is less than 50. So you can list down all those prime numbers, 2-digit prime numbers that are less than 50. And what are those? 23, and then next is 29, then 31, 37, 41, 43, and 47. So these are the possible answers for BA. Okay, 2-digit prime number that is less than 50. So going back to the problem, it says that BA is a prime number less than 50, while AB is a number divisible by 8. So you simply look at the number, or find the number among these numbers in which when we interchange the ones and the tens digit will give us a number divisible by 8. Which of the numbers will give us a number divisible by 8 if we interchange the tens and the ones digit? That is clearly, obviously, 23. Because if this is our BA, the AB will be, if this is our BA, our AB will be 32. Okay? And 32 is exactly divisible by 8. So this is the answer. The answer, or the 2-digit number AB, is 32. So 32, not 23. Okay? Because the other numbers do not satisfy the first property. Only the first number here, 23, when you flip it over, will give 32, and that is divisible by 8. And that is the answer for the first problem. Now let's go to the second problem. Andy goes east for 12 kilometers, then goes south for 5 kilometers. How far is he now from the original position? Okay, this is a simple Pythagorean problem. So to solve this, we're going to illustrate the problem. So let's mark a point, starting point. And then from that point, Andy goes to the east for 12 kilometers. So this is the east direction. And that is 12 kilometers. Let's say that's 12. And then goes south for 5 kilometers. So from this point now, Andy goes south for 5 kilometers. Okay. And the question is, how far is he now from the original position? So this is the starting point, this is the end point. So the question is, how far is Andy from the starting point or the original position? So we simply need to find this length, okay, from this point to that point. And this is definitely a problem that can be solved using simple Pythagorean theorem, because we have here a right angle triangle. This is a right angle, and we're looking now for this side, which is the hypotenuse of this triangle. So we could denote this side as x kilometers. So to solve for the hypotenuse, simply squared. Get the square of the hypotenuse, and that would be equal to the sum of the squares of the other two sides, or the legs of this right triangle. And the other two sides are 12 and 5. So x squared equals 12 squared plus 5 squared, and that would give us 144 plus 25, or 169. X squared is equal to 169. X is plus minus 13, but we are looking for the positive answer since it is asking for the distance. So we take the positive square root, which is 13. So that is the answer for this problem. A and D is 13 kilometers from the original position. Okay, that's the answer for problem number 2. Now let's go to the third problem. The cost of a teddy bear is $300. If the marked price is $390, what is the profit margin in percentage? This is a simple percentage problem. Okay, the cost of a teddy bear is $300. So let's say the seller or the shop owner buys the teddy bear for $300, and then he or she sold it for $390. It means the profit or the mark price is $90, right? 390 minus 300 is $90. So this is the profit or the marked price, 90. Now we're going to find the percentage of that profit from the cost price or from the original price. So we simply take 90 out of the original price or the cost price of 300. So 90 out of 300 expressed in percentage, so we multiply by 100%. So simply cancel these two zeros, and 90 divided by 3 is 30, and we have the answer, 30%. Okay, so the answer for this problem is 30%. Again, let's review the question. The cost of a teddy bear is $300. If the marked price is $390, what is the profit margin in percentage? So the profit is 90. 90 out of 300, which is the cost price, gives us 30% profit margin. Okay, 30% is the answer. Okay, next problem. Problem number 4. Amy's walking speed is 4 meters per second. She walks from home to the shopping mall and from shopping mall back and forth 5 times in 15 minutes. What is the distance between Amy's home and the shopping mall in meters? Okay, so this is a bit tricky problem. You need to analyze it well. Amy's speed is 4 meters per second. She walks from home to the shopping mall back and forth 5 times. She walks 5 times back and forth. It means she walks a total of 10 home shopping mall or shopping mall home distances. So she walks a total of 10 distances from the house, from her house to the shopping mall. Okay, not 5 but 10, because it says she made a round trip of from shopping mall to her home, or from home to shopping mall 5 times. So that is 10 times of the distance from her home to the shopping mall, and she did it for 15 minutes. Okay, so we're going to divide 15 minutes by 10. Okay, it means one trip from home to shopping mall is equal to 1.5 minutes or 90 seconds. Okay, 90 seconds from home to shopping mall, that's 1.5 minutes or 90 seconds. All right, her speed is 4 meters per second. So in 1 second She walks 4 meters. So in 90 seconds, how many meters? Simply 90 times 4, 360. And this is the total, this is the distance from her home to the shopping mall, 316 meters. Okay? That's the answer for the fourth problem. Number 5. 12th May 2018 is Saturday. Which year will 12th May be Friday for the quickest case? Okay. First, you need to understand that for the same date, if the year is normal, like it's not a leap year, the same date next year will be 1 day ahead. Okay, 1 day forward. For example, if the date today, like the date today is 2nd of January 2020. Sorry, is it 2nd? 3rd, sorry, 3rd of January. Now it's January 3, 2020, and it's Friday. Next year, usually it will be 1 day ahead for the same date, but since this year is a leap year, it means this February will have 29 days. So it will be 2 days forward or 2 days ahead. Okay, so January 3, 2021 will be Friday, Saturday, Sunday. Okay, that is the logic. If it is a normal year, if it's not a leap year, usually the same date will be 1 day ahead for the next year. But since if there is a leap year, you have to count the 29th of February, so that's an additional 1 day. So this becomes, instead of Saturday, becomes Sunday. So let's go back to the problem. Okay, so 12th May 2018 is Saturday. It means this is Saturday. The 12 May 2019 will be Sunday. Okay, because 2018 is not a leap year. By the way, the leap years for convenience is every 4 years. So and 2000 is a leap year, so you just count from 2000 and add 4 years. So 2000, 2004, 2008, 12, 16, those are leap years. And 20 this year is also a leap year. So 12 May 2018 is Saturday. So the 12 May 2019 is Sunday, 1 day forward. And 12 May 2020 is Monday, just Monday. Do not add 2 days because from 2019 to 2020, we just added 365 days. Okay, and then the 12 May 2021 will be the Wednesday, because we now included the leap year, so we added 2 days from Monday, so that's Wednesday. And then 2022 of 12 May will be Thursday. And lastly, 2023 of 12 May is Friday. So this is what we're looking for. Which year will be the Friday? Will be the 12th of May be Friday for the quickest case, and that will be 2023. The answer for this problem is 2023. By the way, let me explain why is it that every year the same date goes 1 day ahead. It is because we can divide 365 days, the normal year, by 7. If you divide it by 7, you're going to get 52. It means 52 weeks, but it's not only 52, but there's a remainder of 1 day, because 365 is 7 times 52 plus 1. Okay, so 365 or one normal year is 52 weeks and 1 day to be exact. So that remainder 1 day will make the next same date 1 day forward for the next year. Okay, now for the final problem for this logical thinking part for this HKIMO mock test or mock paper 2018 secondary 1 level. The last problem on this first page of the test is this. There are 30 problems in the mathematics competition. The scores of each problem are allocated in the following ways. 5 marks will be given for a correct answer, 0 marks will be given for a blank answer or a wrong answer. Find the minimum number of candidates to ensure that 3 candidates will have the same scores in the competition. Okay? Please read over the problem again. 30 problems in a math test. If you get the correct answer, you will get mark of 5 or you get 5 points. If your answer is wrong, you'll get 0 point. If you leave it blank, you will get 0 or you will not get deduction to your score. So we're going to find the number of candidates to ensure that we're going to find the minimum or the smallest number of candidates to ensure that the 3 candidates or 3 students will have the same scores in that competition. Okay. Since the problem says that if you get the correct answer, you'll get 5 points. If your answer is wrong, 0 point. If you leave it blank, 0 also. It means that the number of possible scores will be, since there are 30 problems, so 5 points each, right? So if you get 1 correct answer, that your score is 5. If you get 2 correct answers, 10. So different number of correct answers, different scores. So that's 30 different scores. But if you don't answer anything or if all your answers are wrong, you will get a score of 0. So that's another kind of score. So the possible scores will be 0, 5, 10, and so on up to 150. Okay, so the perfect score is 150. The lowest score is 0. That's the numbers multiples of 5, including 0. That is 31 different scores. So there are 31 different scores. 31 different or unique. 31 unique or different scores for this test, for this math competition. So the question is, what should be the minimum number of candidates that we will have in the competition to ensure that there will be 3 that have the same score? Okay, to solve this problem, this is the clue here. All the possible scores is 31. Okay, there are 31 different scores. So if you have 31 students, let's say 31 students, you can, the worst case scenario is each of the students have different scores. It could be that one will have a score of 0, one will have a score of 5, one will have 10, one will have 15, and so on up to 150. So if there are 31 students or 31 candidates, the worst case scenario here is there will be also 31 different scores. So there will be no 2 students will have the same score. In order to get 2 students that have the same or will always have the same score, we are going to double this number 31. Okay, double this number 31. In that case, the least or the worst case scenario will be 2 students. Every pair of students will have a unique score. I mean, 2 students will have the same score. Now, from the 31, another 31. So that would be the worst case scenario. If you double 31, so that is 31 times 2, you will get 62. If you have 62 students, you can be certain that at least two of the students have the same score. Okay, but the problem is asking the minimum number of students to ensure that there will be 3 candidates with the same score. So we are now certain that if we have 62 candidates or students, we will have 2 with the same score. So we just simply add one more student. Okay, just simply add one more student. 62 plus one more student, that would ensure that we will have 3 students with the same score. Why? Because that student that we added will have the same score for any of the 2 or at least 2 students among the 62 students. Okay, so the answer for this problem is 63. Okay, so